Hey guys, welcome back to Chris V's RF channel. Excuse me for the long delay from my last video. Had a lot to improve in the program and had a lot to do on my own side of life, and have a lot of other things I needed to do, and work and making money, and this isn't something that's lucrative right now. I don't know if anything will ever happen, but my goal is basically just to, after I'm done with this software, that I could design a radio frequency integrated circuit, starting from designing the preamplifier, then the mixer, oscillator, phase lock loop, all those components that go into a radio frequency integrated circuit, and the analog digital converters and stuff. That'll come later, but this is an update though. I just trying to update a little bit here and there. So let's go ahead and go in first. Show you the process, what I did here, to show more detail in how I got the answers. So you do need to know that you need to place the components on the screen and edit their parameters before going on to the next component. I believe I've shown you how to do that. I showed you that on my other videos, and while placing them left to right on the screen, you need to make sure that you edit them before going on to the next component. Make sure it's going left to right, and that way you can see that the circuit, how it's laid out, going from left to right, from input to output. You may have to restart the program if you put the wrong component down, but you won't have to do that if you go into compdata.txt file and edit it. I will show you how to do that later in this video. But if you use the components, make sure that you place term 1 in the beginning and end with term 2 in the circuit if doing an S parameter simulation. No need for wire connections. The circuit is created based on what the component is placed after the other. So you can put components anywhere on the screen. One here, the next one here, and the one over here, but it won't make sense. It won't make sense that the circuits, you won't know that your circuit is working that way. But it will work that way. So make sure that you place your components from left to right to create the circuit, and edit them before going on to the next component. So here's an update though. In my software, you can match between two terminals. So we can put 30 plus 20i, for example, here. And then 15 minus 30i, for example. Okay. You can go to Smith chart. Here comes up with the two terminals. The terminal 1 and terminal 2 is blue. Terminal 1 is red. So we cannot do transmission line matching because you can only match it to 50 ohms. You can only match it to 50 ohms. with transmission line matching. So if you wanted to do that, you could go here, go back to, you can't go back to the component, you're going to have to actually go into the file, compdata.txt file, go to documents, and it should already be there. Data. Here it is, and you can match it to 50 ohms. And make sure that there's a 0 in the complex, or it won't work. If you just put 50, it won't. The simulation won't work. Okay. So here I have the admittance, input admittance, and then I could match that to your admittance unity circle that goes to your 50 ohms here, and that calculates the distance to the stub. And it gives you all the information on how it was calculated from where it transversed from this point to this point. It shows that it was about 50.6 degrees. Divide that by 720. We have our lambda fact. And wavelength, you need that to, when you multiply your lambda fact with your lambda, your wavelength, that will give you the distance to the stub. And then it ends in a admittance of 1 plus 0.7144J. And you'll see that come up on the next screen, 0.1. So we want to negate it. So we're negating this 7 here. We don't want the complex. We don't want complex values when we're matching. So we want to make sure everything goes to our center of the Smith chart. So all of this is calculated up to, then the length of the stub becomes 2.83 centimeters, for example. So that's for just the 50 ohm match, not a complex impedance. So if it was a complex impedance, it would be a different stub. But you can you can match it with a lump component matching. All you do is re-click on the Smith chart. It gives you your constant resistance. So if we want to match it to here, we could click on constant resistance, go all the way up here, and it'll give us our inductive value for 0.42 nanohenries. That goes up there, and then use a admittance circle. Just ignore this line. It doesn't matter. It's just, all it is just a tracer. Just make sure that you have your button pushed down and that you're dragging the point. You're dragging your mouse down here, and then you unclick, and you come up with your inductance value. You don't need inductance value because we're going down. Going down is capacitance and going up is inductance. So this gives us a value of 1.5 picofarads. So that would give you your matching circuit for that to match between these two complex impedances. So that's that part, and now we need to show you more of compdata.txt file. So if we want to just create the circuit without, you know how I had to do it on my other videos where I place the components from left to right on the screen. We don't have to do that. You can just go into just click on one of the components, for example the S2P file here. We can load it. I prefer that you place the S2P file and load the S2P file if you're creating the amplifier. If you're creating a just a regular matching circuit, you would just place one of the components down. Make sure you have your terminals there, though. And you can also edit that on the compdata.txt file also. So we loaded the S2P file. We can go to File Help and then File Formats. That'll give you how the S2P format is. So it's not like the touchtone format used in ADS. It's a little different. It's a little different. All it is just that it does not contain the text of what the parameters represent. The parameters are represented out from the data sheet, and I keep it that way. I don't want to change the values or anything. So what I have here is I have it in gigahertz. This is the 0.9 gigahertz, and it gives you all the S parameter values for that gigahertz at that point in the S parameters. So in order to create the circuit without having to put all the components on the screen, you can just copy and paste this preamplifier if you're designing a preamplifier. Paste that into your comp data. So you would go into your documents folder and then paste that in there, save it. That gives you the S parameter at 3 gigahertz, your preamplifier there. And you can also make it more fine, the graph more fine, by loading X2 S2P here. It gives you a more fine graph. At 3 gigahertz here. And then the other update here is I could create another circuit here. For example, this I'll do. If I want to stable the transistor using resistor here and load the S2P file. $200. Okay, we can go to the last component here and go to matrix calc. When you see NaN, don't worry about that. Go and redo it again. And that will give you your full S parameter response for the circuit. It's not in dB, so in order to change it to dB, you would just do 20 times the log of 4.1. Gives you your dB value. If you place the microstrip transmission line in there, it will also give you your matrix calc too. You can see how it calculated the matrix for the ABCD parameters. I'm just given arbitrary values here where there, just random values here, so I can show you the matrix calc and how it calculated the the full circuit here. So I kind of placed that after the terminal. It won't work. It's kind of, you would have to put that in between the terminals to see it. Right now that wouldn't make any sense, so it wouldn't make much sense why I would put the transmission line after the after terminal 2. So, but that would probably be another time I could do. Other than that, my next update for my next video will be to create a way so that I can match a 3-port network, because it's important to know that in order to design a mixer. And also later after that, I got a lot of other stuff I have to do too. I need to detail on the lump component matching, the message boxes that come up to show what the capacitance value or inductance value is. I will edit that more to show more detail in how I got that capacitor, the inductance and value. And using complex impedance terminals while using the S2P file. So you can only use just regular 50 and 50 here for now. Do not use complex impedances when using the S2P file. It won't, it's not accurate or something. But if you're doing complex impedance matching between just the two terminals, then you can actually use the complex impedances. But you cannot use it if you're using the S2P file. So that is another thing I'm going to work on my next update for this program. But other than that, I hope this gives you some insight of what's going on with my software and what I'm trying to do in the future here with it. So I hope you like it, and thank you.